Welcome to biostatistics.com. So today I'll be talking about a non-parametric test called the mann-whitney test. So this is a two independent sample non-parametric test. So essentially we will use this often when we do not meet some of the requirements of the parametric tests. So for every parametric test, there usually exists a non-parametric counterpart. And one of the big assumptions that the parametric test require you to know about your data is the fact that your data needs to be normally distributed. So in this case, we'll be looking at a data set that is not normally distributed, but we still want to run a two independent sample test on it. So the way to do this on our biostatistics.com is to go onto our biostatistics tool, go to comparative, non-parametric, and then load the two independent sample test. So the way your data needs to be is so there are some assumptions. So for example, both groups need to be independent of each other. Otherwise, there's other tests that you can perform, as this is a two independent sample. You can perform the two related sample tests if the samples are related. Also, I should mention, to test for distribution of your data, you can also go to biostatistics, descriptive, and then distribution. So once you get here, you'll be able to download a data set as well as see the instructions here for your reference, and then you can click Analyze. And once you're here, the dataset we'll be using is an Excel format, so you can tick this and then select either our example dataset or your own dataset. And it's important to format the Excel spreadsheet the same way that is shown in the example. So each value then has for example, in this case, we're looking at pain score and gender. So each pain score has a gender associated to it on the same line. And then we'll be able to select our variables. So pain score and gender are both our variables. We'll define our continuous variable, which is pain score, and we'll define our two categorical values, which in this case is gender, male or female. At this point, it will show up on the selected columns here, and then if we have a look at the mann-whitney test, also known as the Wilcoxon rank sum test, this will show us the two important values. First of all, it will show us the W value. So this is the Wilcoxon's test statistic, and is essentially derived from the ranking process that Wilcoxon goes through to compare the two samples. Essentially, the smaller this value is, the less likely it is that these two groups will have occurred by chance. So there are available online some tables of critical values, but I can tell you that for our sample size, which is 100, 43 is very low. And then we can have a look at the p-value. So the p-value in this case reveals that there's a very high statistical probability that the two samples are not likely to be derived from the same population. So essentially, both these values put together highlight the fact that our data sets are unlikely to come from the same population. If we have a look at the table output here, we can see that the software recognized that we have stratified by gender, male and female. There's 50 of each, and you will have, so this is a summary of our continuous variables. So you can have a look at your normal descriptive statistics like mean, standard deviation, and the interquartile ranges for your own information. And then if we have a look at the box plot will highlight male and female, so we can see that we have one male outlier, but that our box plot do not overlap at all, which is further reinforcing the fact that our samples are independent. So thank you very much for listening to this video. As I mentioned, in the test page, you'll be able to download this dataset, as well as see a summary of the explanations provided in this video. Thank you very much.